There's 1, 2, 3, 4, 5, 6. There's 7, 8, 9, 10. And this should be the backside of yours. Yes, starts with 2x, 26x. Yeah. All right. This will be out of 2 because you had to do 2 different factoring concepts. First thing in red, you divided everything by 2 to get 2. X squared plus 13x plus 42. That got you 1 point. Your second point would have been writing, I need to multiply to 42 and add to 13, which is, of course, x plus 6 and x plus 7. That gets you your second point. I trust there were no questions. This is the exact same thing. Well, actually, it's not. This one's different. This one is out of 2 as well because even though you only had to do one concept, you had to remember this R. Q plus 21R and Q minus 4R. R. Pirates' favorite movie rating. R. Did I tell you the joke about why pirates never learned to read? No, because they spend years at sea. It's a 21R.
Yeah, that's another joke. I had a joke for you this weekend.
Now this one. What? Why did the cop pull over the van?
No, it was what do you think about it?
Because he wanted to bust a move.
I don't know about that.
Moving van. But if you say moving van, it ruins the joke.
Moving van?
A great many of you here will have tried to do that, but of course you can't. Why?
13 doesn't divide by 3.
13 doesn't divide by 3, so of course you had to multiply to 63 and add to negative 13. And what was it? Are there factors of 63 that add to negative 13? Is it 1 and 63? Is it 3 and 21? Is it 9 and 7? So, is it factorable?
No, it's not.
Does not factor.
Down to factor.
No, that would be DTF, and I'm not saying that out loud. Down to factor, Toj. What do you think it means? Like these first two are DTF. But this guy, no means no, Toj. You don't try to factor that one. No means no.
It's a no, boy.
That's a no. It's a no. That was one of my favorite punk bands in the 90s.
It's my favorite. Me too. I love them.
This one is, of course, 3b minus 4. Oh, that's only out of 1, hey. And 2a minus 7. And that's only out of 1, because that's a GCF situation. Yeah. This one is out of 2, because you should have divided that by negative 1 to get negative x minus 3 plus 4x minus 3, and then negative x plus 4 and x minus 3. Or I would also have accepted 4 minus x and x minus 3, or negative x minus 4, x minus 3. All of that is acceptable for your second mark there.
Mr. Myers.
Over this one or this one? This one up here? Okay. The easiest way to show this, Sebastian, is to see how they're the exact same thing? Okay, so what if I said that was 3bx minus 4x? You would bring out the x, right? Well, that's what I did. It's just a factor. Okay? You cool?
No, I get it.
So, I mean, I wrote this in a bad, normally we would put the GCF first and then the answer, right? So if I were to divide that by the GCF, which is 2a minus 7, they'd cancel, and I'd be left with 3b, right? And then they'd cancel, and I'd be left with negative 4.
Oh, Mr. Myers.
Yeah? Ms. Peters.
Are you cross-eyed? Because you can't seem to control your pupils.
That's funny.
Like,
It would matter. It would matter. That is funny. I like it.
Thank you.
But it doesn't really apply to me. Because by the 11th grade, if you choose not to do what you're supposed to do,
It was just a joke.
no. I'm with you.
Thank you.
I like the joke. I'm just saying it doesn't particularly apply to me in a literal sense.
Okay, I'll find an answer.
Wait, then how did the pirate one relate to
Oh, thank you. The
How does the pirate one apply to me in a literal sense?
Yes. Exactly.
I don't know literal sense.
Thank you, Frog.
All right.
I appreciate that support.
So dry.
This is the exact same question as the previous two. If this was a squared minus 64, it'd be a plus 8, a minus 8, right? So it's x plus 2 plus 8 and x plus 2 minus 8. If you wrote that, you get 1 because you've memorized a step. Of course, you would finish it by doing x plus 10, x minus 6. I know. This one is out of 2 as well. Your first mark is to GCF. And then, of course, you notice that is the difference of cubes, which is 3y minus 2, y squared minus 2y plus 4 for your second mark. Haley. Because x plus 2 plus 8 is x plus 10. If you want to know why it's that one, that's because that is the same as a squared minus 64, which would be a minus 8, a plus 8. No problem. Making the whole quiz out of 2, 4, 6, 8, because that one's out of 2. 2, 4, 6, 8, and 4 is 12, and 10 is 22, or 22.
That's fine. You can help her. Yeah, I first didn't know what was going on. Because I was just annoying, but I was
Oh, sorry, plus there, sorry. Sorry, everyone.
You did it wrong. Why are you saying sorry?
Because I did it wrong.
Are you going to fix it?
I just did.
I have another joke for you.
Okay, hit me.
Which one should we tell?
You got 3 seconds before I'm moving on. 3.
Okay, no, you move on. Oh yeah, that one was good.
okay, ready, Mark?
Is here. Oh, teachers deserve a lot of credit. Of course, if we paid them more, they would have Get it?
Yes,
Rob has
I
to
get
do it
it.
like 3 times.
I get it.
She's like, what? Credit, mine, honey.
I struggle with that.
How do you stop a rhinoceros from charging? You take away its credit cards.
Okay, well, that one doesn't. Rhinos don't have credit cards, though, so that's just.
It's the charge.
So, according to my calculations, dinosaurs studies. Wait, that's so hard. Wait, which dinosaur are we talking about?
Easy job. All right. Apparently, in all sarcasm aside, apparently it was not right of me to expect 65 and 66 done for today.
Most of the class is here.
So,
And yet nobody told me.
so
Come on, this is the only time I've done it. Give me credit.
it's done, right?
Yeah.
So will it be done tomorrow?
Oh, here we go.
So will you get credit for it?
Yeah.
So what are you on about?
I don't want nothing.
So what you're saying
I'm joking about it.
is if there was a ladder away from a fire and you had your friends on lower rungs than you, rather than reach your hand back, you would only offer them your foot?
Why would I reach? It's the ladder. They can reach themselves.
Good to know. Good to know.
I'm not saving anything.
Good to know.
In the fire, I'm
All I'm saying is good to know.
You're on your own problem.
Because I, of course, will be saving every single one of you.
In a fire? I would never.
All right.
Save my cat.
So
I'm so
now,
Haley. That's my mom.
to dispel any possible confusion, pages 65, 65, and its subsequent page 66,
What?
both of which are plainly and clearly marked as assignment in your book and are plainly and clearly before the next new thing that you cannot do without being taught, must be completed by tomorrow morning or whenever you're in this room. First block, because tomorrow's day 1. Clear and recorded for posterity on here. Because as you all know and don't care, anything on the internet is always on the internet. Forever and ever and ever. Please turn to page 67.
Could we do questions 15 and 16 on the assignment?
Tomorrow when we mark it. All right, now listen to me, please. Do you already know how to handle radicals? Yes. Do you already know how to do equations? Yes. So we are going to put the two of them together now. We are going to start you will notice there is very little room for notes here because you already know how to do this, even though you think you don't. Okay? So let us attempt it. On the left over here, we are going to write a very simple 2-step algebra equation. The hint here is it will take you 2 steps to solve it because it is called a 2-step algebra equation. Without asking for assistance from me or from the kid sitting beside you, all of you please try to solve this equation. No, you should do this. Yes, you should. You do know. So do it. Good. Now, Some of you in this room are able to do that in your head. And that's fine. It's super cool. It's going to be helpful, but it's super cool if you can do that in your head, but also pretty useless for this class because there's a lot more going on than that. So of course, just to remind you, the longest possible way to do this would be to do it the way you were taught in grade 6. Take away 10 from both sides. 2x equals negative 30. X equals, divide both sides by 2. X equals negative 15. And you could all do that. You all are capable of doing it. And, of course, you're capable of checking it. How do you know this is the right answer? Because x equals negative 15. 2 times negative 15 is negative 30. Negative 30 plus 10 is negative 20, so you did it right.
Whoa.
Okay? Now, what if I gave you this one? It would be a little awkward for both of us, I think.
I love you.
Okay. I'm all right with it. I'm pretty secure. What if I gave you this? Could you solve that one? Please do so. It says 79, yes. Now again, you can do this in a very long process, the way you were taught how to do equations in the early days, or you can employ a couple of shortcuts that you probably have picked up along the way from various math teachers, or even devised for yourself. Okay. Some of you will probably have at some point been said or been told, always move the smaller x. Nobody's been told that?
I use the bigger one.
Okay. So some of you may have been told, always get the letters on the left. L for letters, L for left. I didn't say you all would have, Sophia. That's why I said some. Some of you will simply have been told to isolate the variable. Some of you will have been told to show all your steps. For example, you would do this work over here. Some of you will have been told just move the stuff. There's all kinds of ways to do this. Some of you will even have seen this weird scale thing where they draw 3 X's and 7 of these. And then over here, they draw 9 X's in a different color, and they want you to balance it on a scale. There's so many ways to do algebra. I don't want to have to teach them all, okay? So I'm going to rely on the 3-word answer. Isolate the variable. Isolate means get the letter completely alone. No number near it, no sign near it. Letter alone. So for me, the way I would do this, I would move this 9 over here, and it would become positive. That means this 7 is in the wrong spot, so I would move it over here, and it would become negative. And I would get 12x equals 72, and x would equal 6. I don't care how you did it, but if you aren't able to get x equaling 6 here, I need to see your name up there for X block, because you need to be reminded of how to do algebra, or you're not going to be able to do this part of the unit. Okay? I'm not being mean. I'm not being an a-hole. I just need you to be able to do algebra to do this. Can everybody move around an equation? Honestly. You don't have to nod. You don't have to do anything stupid. You don't have to, give me a red light, green light, orange light, or 1, 2, 3 fingers. In your own head, yes or no, can you do basic algebra? And if the answer is yes, we can go on. All right? If it's not, you got to go see somebody or go on the internet, get some basic algebra lessons, do something. Everybody cool? Okay. Now, notice what we are doing is called radical equations, yes? Have we covered equations? What are those? Yeah. So we better talk about the radicals, yes? All right. Before we talk about radicals, let's talk very simply. What if I gave you this? You have to take the square root of 9, yes? Because we have to do the opposite of what we see, right? We saw subtract, we ended up adding. We saw add, we ended up subtracting, right? So this becomes x equals the square root of 9, yes? Right? Because I took the square root of both sides to eliminate that. Is everybody cool? Okay. Now here's where it gets this is where it's going to get a little snaky. What is the square root of 9? What's the other square root of 9? Negative 3. Everybody understands that, right? That's the first new thing today. This symbol means we want what is called the principal square root. I don't want to say square, because if it was cubed, right, we'd want the principal cube root. We want the principal root. Everybody cool? Which is positive. But in reality, this really has two answers, doesn't it? Positive or negative 3. Is everybody cool with that? It's not news to you, but it's going to be important in this unit. Is everybody all right with that? So everybody understands the idea of inverse operations to solve algebra, right? If we see add, we do subtract. If we see multiply, we do divide. If we see divide, we do multiply. If we see subtract, we do add. Yes? So if we see squared, we square root. What then logically should we do if I gave you this? Square root of x equaled 15. What would you do? Square it, right? We square both sides. The square root of x squared is x equals 225. Is everybody good with the top of this page? I'm not saying you can do algebra perfectly in your head. I'm saying you can follow this. Everyone's cool? Okay. So let's look at our very first question here. And the instructions have a word that makes very little sense right now, doesn't it? What word there bothers us? Restrictions, right? Restrictions is new to us. What does the word restriction mean? You can't do it, right? We all know what an R-rated movie is. You can't go see it without mom or dad or a grown-up, right? That's what restricted means. There's rules about it. So the first thing we got to talk about are restrictions. And restrictions are simply numbers we can't use. And believe it or not, you already know this, okay? Who remembers, and I don't know if anybody will, but it would be really nice if somebody did. Who can remember the proper definition for a rational number? rational number. You've got notes on it, but if you forget, it's no big deal because we don't talk about it a lot. We use the word rational number, but we don't talk about what it really means a lot, right? So does anybody remember? Okay. You don't need to write this down. It's just, it explains restrictions. So a rational number is this, yes? We remember seeing this, right? And what was special about A and B? They had to be something. They had to be, again, it's a math word. If you don't remember it, it's not important. They had to be integers, right? So like -6/7. Everyone's cool. Everyone remembers this a little now, yes? But B wasn't allowed to be something. What? B can be negative because we could have 3 over -2. B cannot be irrational, right? So I could never have the root of 2 under there. That's a restriction. Everybody cool? And the other restriction is B. B can't be irrational. And B can't be 0 because we can't divide by 0. Everybody's cool? So we're already used to restrictions. We just weren't calling them that. Everybody's okay, right? Okay, let's come back to where we were. Numbers we can't use. Well, where in here is the only number we don't know? Where's the only place a restriction might happen? X, right? Because everything else there, 5, 2, -1, 12, we all know what they are, right? But we don't know what X is. So the restrictions, if they exist, have to be something to do with X. So when we do the work, when you learn how to do the work, you're going to end up with X cannot equal something. Now, maybe there are no restrictions. But if there is, that's how we write them. Now, it's always good to get your restrictions out of the way first. So since X is involved in this, square root 2x minus 1, what's the problem with that? Can you think of a situation where this can't happen? What if I told you X was 7? Could we do this? What would it be? If X equaled, it would be the root of 15, which we can do, can't we? It's irrational, but we could do it, right? We would look for pairs. Oh, there are no pairs, so we'd leave it as root 15. Or we'd go to our calculator and find out it was like 3.87, right? Everyone's cool with that, right? What if I told you that X was -7? What's 2 times -7? -14. What's -14 minus 1? Can I have a square root of a negative number? No. So are there restrictions on X? We know that anything under there can't be negative, right? Because you can't have a square root of a negative number. Is everybody cool? So we know that this expression right here can never be negative, right? So how do I figure that out? You have to think back to grade 9 now. You have to isolate it. But we've got rules now, don't we? Because the whole thing can't be negative. How do you show me, thinking back to grade 9 if you can, and this is the problem with the way we teach math in Canada, you haven't done what you need now, today, since the 9th grade. And in the 9th grade, your teacher didn't say, you're going to need this in the 11th grade, keep it. You're not going to. Right. It's just the way we teach math in Canada and the States. I don't like it any more than you do, but we're stuck with it. This has to be positive, yes? So it must be greater than 0. Remember seeing this in the 9th grade? Okay, then we better talk about it. Could you all solve that? What would you do? 2x would equal 1 because you'd bring that over. And x would equal 1/2, yes? All right. So what do you think, logically, you would do with that? If you don't remember. Logically, what would be something you would try? You would isolate the x, right? So 2x would have to be greater than 1, and x would have to be greater than 1/2. Does everyone agree? Okay. So let's just check something. There's a number line, yes? Everyone agree? 0. There's 1, yes? Where is 1/2 on that number line? Right there. Everyone cool? Is this value, the number 1, is that greater than 1/2? It is, right? Because it's on the right. Everyone agree? Okay. What is 2 times 1? What is 2 minus 1? 1. Is 1 positive? So is that point okay for x? Could x equal 1? Everyone agrees? Okay. What if I use 2? Could x equal 2? What's 2 times 2? Minus 1. Is that positive? Can we have a square root of a positive number? So that would be okay. 2 would work as well. Would 3? Would 4? Would 5? Would 6? Would 7? Would 8? Would 1,000,000? Okay. Would 0? Why not? Because 0 minus 1 is negative 1. And 0 is to the left of our half. X would have to be any number greater than 1/2. Because that would keep this positive. Is everybody good? Okay. We're not going to spend too much time on restrictions because they come into play a little more later. And sometimes it's okay and sometimes it causes a lot of grief. So, we've already done our restrictions. When we solve this, our answers have to be greater than 1/2. Everybody cool? That's what the restrictions mean. So let's have a look at this. What is our job whenever we have an x? Isolate it, right? Okay. So what do you think is the first thing we should do to isolate that x? Get rid of the 5? How do we get rid of the 5? We move to the other side and it becomes negative. So if I come over here, it's going to be negative 5. And now I have 2x minus 1 square root equals what? 7. Is everybody cool? Okay. Now what is the next thing in the way of x being by itself? You see a square root there, right? I can't get to that x because it's in the radicand. How do I get rid of a radicand? So if I square this side, what do I have to do to this side? Square it. What's going to be on the left now? 2x minus 1. And what is that going to equal? 49. Now what are you going to do? Doesn't this look... And this is like back to grade 6 algebra all of a sudden, isn't it? Right? So, change colors, bring that over, becomes plus 1. 2x equals what? 50. And our last step. And x equals... Now, is 25 greater than 1/2? So it's possible that it's our answer, yes? Let's check. What's 2 times 25? What's 50 minus 1? What's the square root of 49? What's 5 plus 7? That's where we stop. 5 plus 7, dead silence. You guys are squaring, you're dividing. Okay, yeah, what's 5 plus 7? Crickets. 5 plus 7. 12. So this side is 12, isn't it? Didn't it have to equal 12? So are we cool? Easy peasy, right? Okay. Now notice how normally I give you a framework within which to work, yes? But did we need a framework here? No, you figured it out all by yourself, right? What did we do? What's the first thing we did? We dropped the 5 so the radical would be alone, yes? So the first thing we did was got the radical by itself. What's the next thing we did? Got rid of it by doing what? Yeah? Squaring it. What's the next thing we did? We squared both sides. And then we did grade 6 algebra. If it worked here, will it always work?
Yeah.
Let's try. What's the first thing we should do here? What's the first thing we did here in A? We got rid of the number for what purpose, Sebastian? To isolate the radical. Right? Just wait a sec. We have a radical now, yes? I want that radical isolated, which means it's by itself. Is there allowed to be a negative in front of it? No. So what can I do with that whole term if I want to get rid of that negative? If I move it over here, what's going to happen? I'm going to have root 5 minus n, yes? Now, but there's already a 7 over here. So I need this guy isolated, yes? So I better move the 7. What happens when I move the 7, Bea? It becomes positive, right? Are we cool? We've isolated the radical, haven't we? That was our first step over here in red, yeah? Now what do we want to do? We got to get rid of the radical. Getting rid of the radical is easy. What do? Square it. But we got to remember to square both sides. Uh-oh, it's a good thing we're in the middle of our polynomial unit, isn't it? Because what is that squared? Plus what? Equals what? No. Look over here. Use your prior knowledge. When you square a square root, what do you get? I'll come back to that in a sec, Bea, okay? I just want to make sure we're okay here. When you square a square root, what's the answer? The radicand. So what's going to be on this side? 5 minus n. Now, Bea is wondering what happened here. When I squared this side, I get n plus 7 times n plus 7, right? N times n squared. 7n and 7n, 14. 7 and 7, 49. Everybody cool?
Yeah.
Okay. Now, we did a bunch of that this year, right? At the beginning of this unit, we reviewed that. Yeah? Okay. Now, again, stay cool, stay the course. Your job is to isolate your letters, yes? Okay, well, I got a letter over here, a single n, and I got an n here. They must be put together, right? So what should I do with that? I need to move it over here so the n's are together, correct? What will happen to it? So I will have n squared plus 15n. Okay. Now what should I do with this 5, do you think? Because n and n squared cannot add together. They're not like terms. Now, we're going to do something weird here. Okay? You want to bring this 49 over with the 5, don't you? Yep. So you would get n plus 15n equals negative 44. That's what you want, right? Yep. Okay, watch this. I'm going to bring the 5 over here. And I get, what happens to it? plus 44, yeah? What did I leave over here? Okay, is everybody cool?
So if I did it that way, am I wrong?
No, I'm just stay cool, okay? Are we good to there? Okay. Does this look like something we have dealt with? How? I did it on purpose. I want you to talk to me. It is now. That looks a lot like the factoring we just did, yes? Right? The only difference is now it says equals 0. Up until now, we've just been factoring, yes? So I need numbers here that will multiply to what? 44. And add to what? What are they? Is everybody cool? All right. Now what you're going to see here is new, so you need to pay attention. Because until today, that's been what it looked like, right? There's been no 0, yes? It's never equaled anything. We've never been able to find an answer, have we? We've only been able to simplify. Is everyone good? All right, but now it equals 0. Now you're intelligent young kids. This is a little weird though. You've got to really follow me on this, okay? What math is happening right there? Multiplication. If you are going to multiply and have the result be 0, then what must one of these factors be? 0, right? Everybody cool? So either, and I'm going to use 2 different colors, either that has to be 0 or that has to be 0. Do you all agree? All right, which means that either n plus 11 would have to equal 0, or what? Would have to equal 0. Now, can we solve these? What's our job anytime we see a letter? Isolate it, right? How are we going to do it in this case? You're going to move it over, right? So n would have to equal negative 11. Everybody cool? Or n would have to equal what? Now let's see if that works. If n is negative 11, what's negative 11 plus 11? 0. What's negative 11 plus 4? Negative 7, right? What's 0 times negative 7? 0. Everybody cool? If n was negative 4, what's negative 4 plus 4? 0. What's negative 4 plus 11? 7. 7 times 0 would be? So this question actually has 2 possible answers. Is everybody cool? Yeah. And that makes sense because square roots have 2 possible answers. Right? What's the square root of 9? Positive or negative 3. When we have a square root, we have 2 possible answers. But we have to be worried about restrictions, yes? What is our restriction here? 5 minus n could never be what? 5 minus n cannot be less than 0, yes? So it has to be greater than 0, yeah? Everybody cool? So negative n must be greater than negative 5, right? Because I leave the n there. I move the 5, yeah? Then I divide both sides by negative 1. Now, what's negative 5 divided by negative 1? Positive 5. Now, somebody must remember this. If I divide by a negative, what has to happen there? It switches. So n, whatever answer I get for n, has to be less than 5 if it's going to work. Are both of those answers less than 5? They're both negative.
Also, I thought you meant 11 and 4.
No. Is everybody cool? Now, this is a lot of work, right? We should check if we're right because we don't want to do all this work and hand it in if it's wrong. So, start with negative 11. What's 5 minus 11? 16. What's the square root of 16? 4. So negative 11 minus 4. Is that negative 7? Crickets. No, it isn't, is it? So is negative 11 actually a right answer? No. Let's check negative 4. Negative 4. What's 5 minus negative 4? 9. What's the square root of 9? Is negative 4 minus 3 negative 7? Yes. So which of these is the actual answer? Only negative 4. Crazy, hey? Now, some of you, one or two of you at least, should be saying, how can I have two answers that work, but only one of them works up here? Can anybody take a guess as to why, where in all this math, this phenomenon was able to occur? Pardon me? It's exactly because when you square it, good job, Bea, because if you don't square it, right, there's not two answers, right? Once we square, we open it up to two different answers because negative 3 and positive 3 both square to 9. Everybody cool? Are you guys getting like a translation into French or something from what I'm saying? That's why you got to have your earphones in? Or is it like an old-timey like hearing aid thing? Like there's a mic down there and it's for that? Or are you not understanding my sarcasm and get the things out of your ears now because I don't want to see them? Good. We're getting to those in a bit. Let's make sure we're comfy with squares before we go crazy with cubes. Okay? All right. So let's look at this one. Our first job was always to isolate the radical, yes? Is this radical isolated? Yeah. So we can skip that step, can't we? So, we'll carry on. So what is our next job? We want to get rid of the radical. So what do? Square the radical. To get what on the right here? 2 minus p. And if I square the right side, what do I got to do to the left side? Square it to get? Yes, Haley.
The first step is to isolate the
Radical. It's already isolated. All right, now, we've got two letters, yes? You should all look at that and see p squared, p, and a number. Wait a minute, that's a trinomial. Make it a trinomial. So what should move? Where do we not want a negative? In all of the factoring we've done, where were the places we were trying to avoid a negative? With the squared, right? Is this guy positive? So should we touch that guy? No. He's going to stay right there. What's going to happen here? P squared plus p minus 2. Let's keep it in the order we're comfortable with, yes? Now, does that look like something we've dealt with?
Yes.
How do we deal with that? Multiply to negative 2 and add to 1. What is it? P plus 2 and p minus 1. How do I solve this? If this is true, what do I know about p plus 2 or p minus 1? One of them has to equal 0, yes? So what are my two options for p? P is either negative 2 or positive 1. Everyone understands? How do I check? Whoa, where were you lost? You were cruising along.
I said I'm hungry.
Oh, I'm just so used to hearing I'm so lost. I kind of stopped listening after I'm so. I'm hungry too, babe, because I have to be on a fast until 3:30. Because I have to go get a blood test.
You can do that?
Yeah.
I don't think I did that one.
Look at how old I am.
Oh.
I have to go for a blood test because I'm taking a medicine that might ruin my liver.
You need to get a blood test.
Alcohol.
Yes.
Drink
Huh?
all the
Even
junk
a blood test
food.
and me with that.
It depends on what the blood test is. I am getting a blood test. My blood test, they are checking everything. Well, they don't do physicals anymore. They just take your blood and send it to the lab. Yeah. It isn't. It's kind of boring, actually. And it's not as satisfying either. Like I go to the doctor, zink, zink, fill up 3 things of blood, there, you're done. And then they don't even say, oh, you're in great health. If there's nothing wrong with you, they don't even tell you. Yeah.
Call you.
So anyway, I got to fast for 10 hours. But I couldn't get an appointment in the morning. My appointment's at 3:45. So I haven't had any food since 9:30 last night. So I might be a little snappy. I'll be okay. I got a little bit of reserves, Haley. I think I'll make it. I'm pretty sure they could tell me to fast for a week, and I'd probably be okay. All right. So, how do we check if these are correct? I just go back up to the top. P could be -2, right? So what's 2 minus -2? +4. What's the square root of 4? 2. Square root of 4. Now, doesn't the square root of 4 equal -2 as well? It does, right? Because -2 times -2 is 4. But I told you earlier, the one new thing, what does that symbol mean we're looking for? The principal root, which is the positive one. So is -2 okay here? No. Let's check 1. What's 2 minus 1? 1. What's the square root of 1? Does the square root of 1 equal 1? So that is my positive or my proper answer. But there's one other thing I have to remember. 2 minus P had to be greater than 0, yes? So -P had to be greater than -2, so P had to be less than 2. Is P less than 2? So we're good. Is everybody ready? All right, the day is almost over. Try D by yourself. Go. And then we will continue with this tomorrow. Now, you will notice this unit ends at 3:3, yes? 3-3. This is the last section of this unit. Okay? I want, in a perfect world, I want to send you off into spring break right here.
No work?
At the end of a unit. The only problem with that is that means your cumulative would be after spring break. There's a 2-week layoff, but in that week you come back, I can do a warm-up every day of stuff from the previous 3 units until you're ready.
Question. So does that mean we're going to have a test at the end of the week?
You will have a test this week.
Okay, good. So I was going to say, I can't do a test.
You will have a test this week. That's what I'm trying to do. I'm trying to set it up so you go home with nothing from math class. Because I cannot guarantee the rest of your teachers are doing that.
And that's why we're in class lesson Friday, bio class Thursday, Wednesday presentation.
Go.
And on top of that, math class. I have not very much stuff for.
Go, go, go. Go diddly go.
Okay, I'm